Hi everybody, I hope you've had a chance to try these problems already. Let's go through them and talk about the solutions. The directions say solve for x, express your answer using a decimal approximation. So remember, if we're solving for x, we go backward in the order of operations. Remember, when we evaluate, we follow the order of operations in order from top to bottom. So inside grouping symbols, exponents, multiplication, division, adding, and subtracting. But when we solve, we have to by undoing, we have to go back up the order of operations. So first, let's get rid of any addition or subtraction that we've got. And this minus 9 can be gotten rid of, so we add 9 to both sides, and I've got log base 8 of x plus 10 divided by 12 is equal to 15. And then I'm going to multiply by 12. I'm going to get rid of this division by 12, so I multiply by 12 on both sides. And I get the log base 8 of x plus 10 is equal to 180. And now to undo this logarithm, because remember, if I go back up, I get rid of exponents and functions next. I got to undo the logarithm. That means this is the base, this is the power, and that's the exponent. So I've got x plus 10 equals 8 to the 180th power. That's going to be a gigantically huge number. To finish solving, if I want to get x by itself, 8 to the 180th power, I got to subtract 10 from both sides, and so I get x equals, now I can't do 8 take away 10, because here, if I want to evaluate this, I've got to evaluate that exponent first. So I'm just going to leave it as 8 to the 180 minus 10. That's an exact answer. On the calculator, if I do 8 raised to the 180 minus 10, I'm going to get an overflow error because that's such a huge number. So this one we actually can't do a decimal approximation for. Not with the calculator I've got anyway. I may need a more powerful calculator to do that with. Let's go to the next problem though. Again, solve for x, express your answer using a decimal approximation. So again, I'm going to work from the outside in. I'm going to divide by 5 on both sides, and I get 3 to the x plus 1 minus 8 is equal to 211.2. And so I'm going to get rid of this minus 8 by adding 8 to both sides. And so I get 3 to the x plus 1 is equal to 219.2. Now to undo the exponent, I have to do the logarithm. So it's going to be x plus 1 equals, because remember, a logarithm gets us the exponent, log base 3 of 219.2. And then I just subtract 1 from each side. And I can't subtract 1 from this stuff, because the order of operation says when I'm evaluating this, I can't do the subtraction until I've taken care of the function. So an exact answer is x equals log base 3 of 218.2. And if I want to evaluate that, I've got to use that change of base formula. Remember, that's log base b of n equals log of n divided by the log of b. So the log base 3 of 218.2, I can write that as the log of 218.2 divided by the log of 3. And now I got to use my calculator for that. So on my calculator, remember, I got to do 218.2, take the logarithm, divided by, I got to type in the 3 first, and do the logarithm of 3, and then equals gets me a final answer. So it's about 4.902. This last problem, if I subtract 12 from both sides, I get 6 to the x is equal to negative 28. The problem is, if I try to raise 6 to a number, I'm always going to get a positive number. I can't get a negative answer. So the answer here is going to be undefined. There is no solution to this. And if I try to convert this to a logarithm, I'm going to run into trouble, because it would be x equals log base 6 of negative 28. Using the change of base formula, log of negative 28 divided by log of 6. And if I bring my calculator back up and I do negative, let me clear that out, negative 28, negative, and I take the log of it, it tells me invalid input. I can't do that. I hope that makes sense. Try the homework, please.